Hi guys, welcome back to my channel. In this video, I'll be taking you through the Rolle's theorem. Rolle's theorem is used for analysis of functions. So, in calculus, if I give you a function f of x with certain criteria, you can be asked to show that the function satisfies the Rolle's theorem. In most problems, you'll be asked the values of x that will satisfy the Rolle's theorem. That will make the function satisfy the Rolle's theorem. Now, what's the Rolle's theorem saying? If I have f of x as I'm written here, if I have f of x as I'm written here, and f of x is continuous, when I say continuous, it means that there is no break. Okay, so f of x is continuous over an interval ab. So let me draw this graphically. So I have an interval, here is x, here is y, and I have point A, I have point B. So what I'm saying is f of x, which is my function f of x, is continuous. So starting from A, yes, it will move towards B. Yes. Now our f of x is continuous over AB, that is what I've shown. Then 2, f of x should be differentiable. So meaning that our function should keep on changing. Okay, now if you should have had a straight line, you realize that there wouldn't be any change in the parameters or in the variables associated. But once you say that f of x is differentiable, meaning that you can find a gradient at what different points and it keeps on changing. So far as you have an interval ab and the function which is continuous over this interval, and the function is what differentiable, meaning it has what wings or it keeps on changing, provided that our function f of a, that is the function of a, is equal to the function of b, that is the output of a, the output of b are all equal, then you say that this function here should have at least one critical point. So you say that there is a number c such that f prime of c is equal to 0. I come again. Rolle's theorem is saying that if you have interval ab and a function defined over this interval f of x, so far the function is continuous, doesn't break, and the function is differentiable, that is, it keeps on changing, has works, then there should at least one critical point. Because once ever you have a changing function, meaning that it will move higher and it will decrease at a point. So once it's differentiable and it's continuous, then we should expect at least one. So it can be one, let's say it can be something like this, something like this. It can also be something like this. So there should be at least one critical point. It can be two, it can be three, but Rostrom is saying that there should at least a number c so that f prime of c will give us 0. And you know this is what the condition for a critical point. So let's see how problems on Rostrom are set. So you ask typically here. So let's see. It says verify Rolle's theorem for the function f of x is equal to x squared minus 4x plus 3 on the interval 1, 3. So if you have to verify Rolle's theorem, meaning that you are looking out for C, which is a critical point. Now, to start with, you need to test if this function satisfies the Rolle's theorem. This is my A, this is my B, that's the endpoint. So for the Rolle's theorem, you have to first test for your endpoint f of A, and it should be equal to f of what? B. So what is f of A? I'm going to have f of what? 1. From here, my A is 1. And that will give me 1 squared minus 4 multiplying 1 plus 3. This is giving me negative 3 plus 3, which is 0. Then I'll find f of b. You know, b's here is what 3. So f of 3. And that is giving me 3 squared minus 4 by 3 plus 3. This is 9 minus 12 plus 3. 12 minus 12. This is also 0. Since f of a is the same as f of b, yes, my function satisfies the rule theorem. Now, for continuity, once you have a polynomial, there won't be any number or any point that will make this function discontinuous, right? And this function can also be differentiated. So, meaning Rolle's theorem can be satisfied. Then, what is the Rolle's theorem here? We need to find c, so that f prime of c is equal to 0. So this is what you do. You want to find f prime of c for 0. So first of all, you find f prime of what? X. And that gives us what? 2x minus 4, this one. Then you find f prime of c, giving me 2c minus 4, and it should be equal to 0. So therefore, 2c minus 4 should be equal to 0. 2c is equal to 4, then c is equal to 2. So meaning that at the point 2, our function will have what? A break, or it will have a gradient of what? 0. And that's what the Rolle's theorem is saying. That if you have a function which is continuous, a function which is differentiable, and also having the endpoints, functional value for the endpoint to be the same, then there should be at least one critical point. Since this function here satisfies the Rolle's theorem, and indeed it had one critical point, meaning our Rolle's theorem has been proved here. Thank you for being with me in this video. See you in the next section.